Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into Beyond Blackouts, how power quality breaks building tech, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production. Joining me today is Michael Harrington, and together we'll break this down from a practical, real-world perspective.
Quick cold open. Imagine a law firm on the 12th floor where the lights never go out, but the phones and the VoIP gateway reboot 3 times a week. The building's backup generator ran fine during testing. The UPS shows green, yet tenants keep calling for service tickets. What was missed? This episode starts there, with the silent failures that don't look like blackouts, but still force tenants to call the landlord.
From an operational standpoint, that scenario is frustrating because the first instinct is to point at big visible failures, a generator test, a breaker trip. But what breaks everything quietly is power quality. Voltage sags, momentary transients, harmonics. They don't always blow fuses, but they age equipment, confuse UPS logic, and create intermittent faults that are hard to reproduce.
Before we get into fixes, let's set the record straight. How does power quality differ from a full blackout? And why should building owners and IT leaders care now more than ever?
A blackout is binary. Power lost, services down. You switch to backup. Power quality is the slow, sneaky problem. A voltage sag reduces the available voltage for a few cycles. Spikes are brief overvoltages. Harmonics are distortion introduced by nonlinear loads, like variable speed drives and certain LED drivers. Modern networking and control electronics are far more sensitive, and even short disturbances can cause reboots, data errors, or marginal UPS behavior. Tenants may not see a breaker trip, but they feel the impact on devices that stop working or behave unpredictably.
Segment 1. Causes and signals. Michael, what are the usual operational causes you see in commercial buildings, and what are the quick warning signs facilities teams can watch for?
Common causes are surprisingly mundane. Large motor starts, chillers, rooftop makeup air units can cause short voltage sags. Shared electrical loads on the same phase from tenant equipment can create uneven loading and harmonic distortion. Aging UPS systems with mismatched battery capacity or outdated firmware can misinterpret transients and transfer inappropriately. Poor grounding and loose neutrals create voltage imbalance and intermittent overvoltages. As for warning signs, recurring unexplained reboots of network switches or phones, flickering or dimming LEDs, UPSs reporting short symmetric transfer events in their logs, and thermal hotspots on panels or bus bars during routine infrared scans.
So, if a facilities tech walks into a telco room and sees intermittent alarms, what's a lightweight checklist they can run before calling an electrician or ordering a big capital project?
Start with data you already have. Pull UPS event logs and correlate timestamps with tenant incident reports. Check building automation logs around HVAC cycles. Do a visual inspection. Loose breakers, corroded connections, or overloaded panels are obvious and fixable. Use a clamp meter to look for phase imbalance on feeder conductors and do a quick infrared scan for hotspots. If you can borrow a basic power quality logger for 24 to 72 hours, capture voltage and current waveforms around peak load times. That often exposes sags and harmonics without invasive work.
Segment 2. Trade-offs and mitigation. There are several mitigation options we've seen: centralized power conditioners, UPS resizing, grounding fixes, and localized redundancy. How should teams think about trade-offs between operational fixes and capital-heavy solutions?
It comes down to risk, frequency, and criticality. If an issue happens once a year during a specific chiller startup and it's tolerable, a simple operational workaround, adjust HVAC start sequencing or add soft starts to motors, may be enough. If sensitive systems reboot weekly, you need targeted electrical intervention. Centralized power conditioning reduces distortion for many tenants at once, but it's expensive and requires downtime. Upsizing or modernizing UPS can improve ride-through and filtering, but it's a capital project and introduces maintenance overhead. Localized solutions, like dedicated tenant circuits, point-of-load UPS or PDUs, and surge protection, are lower cost and quicker to deploy, but don't solve building-wide harmonics. Prioritize by asking, how often does it occur? What is the tenant impact when it happens? And what's the cost of repeated operational response? That triage tells you whether to patch operationally or escalate to capital.
Are there common mistakes you see when teams choose the wrong approach?
Yes, the classic is treating the symptom instead of the cause. Teams add more UPS capacity to avoid reboots without addressing harmonics or grounding issues. The UPS hides the problem until it fails. Another is over-specifying centralized gear before collecting baseline measurements, which wastes budget. And a practical mistake? Not including power quality requirements in tenant build-out standards, which shifts the burden back to operations after the tenant moves in.
Segment 3, Real-World Examples. Can you share 2 concise cases where modest interventions stopped recurring incidents?
Case 1. A multi-tenant office where LED lighting and some older variable frequency drives created harmonic distortion that intermittently tripped network switches. The initial reaction was to replace the switches, but logs showed frequent low voltage notches aligned with HVAC starts. The team installed line reactors on a handful of problematic drives, staggered start times for large motors, and added targeted surge protection at the telecom room. Result, reboots dropped from weekly to 0 and tenant complaints stopped without replacing core infrastructure. Case 2. A single large tenant with sensitive lab equipment experiencing unexplained equipment resets. UPS logs showed short transfer events that weren't long enough to look like outages. A short-term rental of a power quality logger captured repeated high-frequency transients at a feeder panel. Investigation revealed a deteriorating neutral connection in a nearby distribution transformer. Repairing the connection and retuning the building's grounding reduced transients immediately. The tenant moved from constant incident calls to normal operations. The capital intervention was surgical, not wholesale replacement.
Those are great examples. For teams listening and trying to prioritize next steps, what are 5 clear actions they can adopt right away?
5 practical actions. 1. Add power quality checks to regular maintenance. Include quick voltage checks and infrared scans in your PM program. 2. Correlate UPS and BAS logs with tenant incident timestamps before assuming equipment replacement is needed. 3. Use temporary power quality loggers for 24 to 72 hours during peak operations to capture sags, spikes, and harmonics. 4. Prioritize fixes by frequency and impact. Short-term operational changes first, targeted electrical repair second, full capital projects last. 5. Update tenant and procurement standards to require minimum power quality and dedicated circuit information for sensitive loads so problems are addressed at handover.
Solid, actionable guidance. If a listener is ready to escalate beyond maintenance and wants resources, where should they look?
Visit the Built, Wired, and Secured show page at GDS Technology for episode notes, measurement checklists, and links to power quality logging resources. You'll find a short checklist you can drop into your maintenance program and a decision matrix to help prioritize capital work.
And one last operational thought. Ask yourself, what breaks if this goes down? Map that to the cost of recurring trouble calls. Often that math makes the capital investment obvious.
That wraps up today's episode of Built, Wired, and Secured. We covered the hidden risks of power quality, voltage sags, harmonics, and transients, and gave practical next steps to detect and prioritize fixes so you can stop recurring tenant disruptions. Thanks for spending time with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world. Built to last, wired with intention, secured for the real world.